Hey everyone, welcome back. Let's talk about another easy problem on Leetcode today, middle of the linked list, Leetcode 876. Even though it is an easy problem, it often appears as a problem in other challenges, and the techniques learned here are widely used to solve more complex linked list problems. Now let's quickly go through the problem statement. In this problem, we are given the head of a singly linked list and we have to return the middle of the linked list. If there are two middle nodes, then we should return the second one. Then in example 1, we are given the linked list with 5 elements, where the middle element will be the third one with value equal to 3, which we will return as the answer. And note that we are returning it as a pointer and not unlinking the remaining nodes. That's why the output may appear as a list containing the elements 3, 4 and 5, but in reality, we are just returning the middle node. Similarly, in example 2, for the given linked list, there are 6 elements. So we will have two middle elements, which are nodes with values 3 and 4, and we return the second middle node here, which is node 4. Now in terms of solution, one of the simplest ways to first traverse the entire list to calculate its length. For example, here the length is 5. And once we know the number of nodes, we can easily figure out which node is the middle one, because it will be at L by 2 distance from the first node. So here L is equal to 5. So the middle node here will be 2 nodes away from the first node. So we will again traverse through the list to simply reach that node. So for second traversal, initially the pointer here will be at the head node. And now we have to move it 2 positions forward, which will bring us to this node, which is 3. So we will return 3 as our answer. But suppose if there were even number of elements, say we also had the node 6 here, then the length L of the linked list would have been equal to 6 and L by 2 will be equal to 3. So now this time we will be moving 3 nodes forward, which will bring us to node 4, which we can return as the answer. Now, while this approach is simple and it works, it requires 2 passes. First time to calculate the length of the list and another one to traverse the list again to find the exact middle node. However, a more efficient and elegant way to solve this problem is by using two-pointer technique, where we have 2 pointers commonly referred to as slow and fast, or tortoise and hare, or walker and runner, both initially pointing at the head of the linked list. And the trick is to move the fast pointer twice as fast as the slow pointer. So for every one step of the slow pointer, fast pointer moves 2 steps forward. And when the fast pointer reaches the end of the list, slow pointer will be exactly at the middle of the list. And this will work regardless whether the length of list is odd or even. Slow pointer will land on the exact middle node. Let's quickly see this in action. So here in the first iteration, we will move slow pointer 1 step forward and the fast pointer moves 2 steps forward. So slow pointer reaches node 2 and fast is at 3. Again, we move the slow pointer forward. It comes to node 3 and fast pointer reaches node 5, which is end of the list. So we will return the slow pointer which points to node 3 as our answer. Similarly, if the list had even number of elements, say 6 elements with 6 element being node 6, in this case, our iteration wouldn't stop because fast is not at the end of the list. So we will again move the slow pointer forward and fast will cross the list and again is at the end of the list. And at this point, we can stop the iteration and we can return the slow pointer pointing to node 4 as our answer. Now we solve this problem just in one pass, and the time complexity of this approach is O of n, where n is number of nodes in a linked list, because the list is traversed only once, and the space complexity will be O of 1, because we are using just 2 pointers, slow and fast. Here is a quick code walkthrough of the algorithm we just talked about, with Java code on left and Python on right. First, let's create 2 pointers, slow and fast, both initially pointing to the head of the list. The slow pointer will move 1 step at a time, while the fast pointer moves 2 steps at a time. This difference in speed is key to locating the middle node efficiently. Now, while the fast pointer doesn't reach the end of the list, that is, fast is not equal to null, or fast is not pointing to the last element, that is, fast.next is not equal to null, then we will move the slow pointer 1 step forward and fast pointer 2 steps forward and continue until the loop terminates. At this precise moment, the slow pointer will be positioned exactly at the middle node of the linked list, which we will return as our answer. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.